Tonight's test is really the culmination of what's been a 3-test series so far to date.
This is a test bed engine. This is an engine that we use in the technology domain that helps us understand the database of knowledge of what it's going to take.
This is a propulsion system test, or at least the engine test, that would be a potential candidate for the descent portion of the lander. It has to perform in a couple of different ways. It has to perform as a lunar insertion orbit burn, which has a different power level, and as you get near the surface, you have to reduce the power level and be able to descend, choose your landing site, and then be able to set down on the lunar surface. This engine has not been used in these environments at this point. They have had throttling, but not to this lower level. This is a demonstration capability to have confidence that the engine can perform and that you can have control when you get down to that point.
Pratt Whitney Rocketdyne has actually been doing high-performance LOX hydrogen engines for 50 years. So it's a great base to begin with, using our people to go explore with NASA as a team how to go pursue deep throttling in a cryogenic engine. And this has been the start, really, of our significant test series.
In this test, we throttle the engine between 100% and 10%. Technically, that's considered deep throttling.
It'll help Constellation with their future work in understanding what capabilities propulsion systems can have. Today demonstrated the full profile of a landing sequence with a throttleable LOX hydrogen engine. So this could have an extensibility towards a Mars vehicle, ultimately for humans on Mars. Today's test demonstrated a pretty big risk mitigation for the future Altair land. It's always non-eventful when things go perfect. That was what we saw today.
We'll be shutting down in 5, 4, 3, 2, 1, shut down.